we operate from the principle that truth is the essence. And so with an open heart, we seek truth. And as it turns out, I think what we're finding is the golden mean number system is at the heart of number theory itself.
Yeah, that's true. This is known to the pure mathematician. But when you move to another culture, another profession, another specialization, because as you said, you need to have the bigger picture, but you need also to specialize. The best thing is that somebody specialize within a culture of many other specialization, and everyone respects the other, and then you come with the truth, because it will be the connection of all this speciality. But it is in reality, on the level of reality, it is not like that. And nothing could be more clear than that. The story of Julian Schwinger. Julian Schwinger, like Richard Feynman, they grew both in Brooklyn. They come from the same heritage. One was very open and talkative and very delightful and extremely intelligent and extremely honest is Feynman. He's extremely honest. But the other one is a little bit quieter, very mathematical, and think in a different way. But he was forced at his, because of the story of free energy and cold fusion, which he believed in and supported. At the end, because they refused publishing his paper, he resigned, and he had a Nobel he resigned from and denounced the system of science dominating America via the web of funding, and he was very outspoken. Until today, his functional based quantum field theory is hardly understood with the majority of physicists. And the lesser, in my opinion, lesser potent theory of Feynman graphs is very popular. If you don't do Feynman graphs, then you are not doing quantum field theory. In my opinion, it is wrong. It is so even on the level of Schwinger,
of a Nobel laureate,
with the same background, with the same everything, like Feynman, but Feynman became more, although Feynman was anti-authoritarian too,
right?
But Julian was completely another way of thinking, which for my thinking is the right thinking, because in a Feynman graph, you emphasize the particle. It's always a quantum particle. Whether the picture is not balanced, because you have a particle, and the surface of a particle, according to my theory, is the wave. So you cannot separate the wave from the particle. And when you have only the particle aspect, you have, roughly speaking, or loosely speaking, half the picture only. Now, in the theory of Schwinger, it's more democratic. It is both the particle and the wave simultaneously play. And through that, I was able to be encouraged to go the way I gone, and I wrote to a Nobel laureate, who was a friend of mine. He never answered about that. I say, it's just like the song of Andy Williams. Can you say to the wave to stop rushing to the shore? Can you say to a baby not to cry? That is how you cannot separate wave from particle, because the wave is the empty set, which is the surface of the zero set, and the zero set is the quantum particle. So how can you have a particle without its wave? It's impossible. And that is the way how it is. with the mysterious wave collapse. Whenever you want to see where is the wave and you catch it, suddenly the wave disappears and you find that you have only a particle. And this really puzzled everybody, including Schrödinger and Einstein. And either Schrödinger or Einstein, or either Schrödinger or Einstein said, if I knew I will end up with this wave collapse, I'd rather be a Schuster than being a professor of physics. But in set theory, it's very simple. When this is the wave, which is our universe. This is the particle, which is our only universe. This is what I want to test. Now, the surface is the empty set. Inside is the zero set. Okay? So this is the wave. I want to see what the wave is. So as soon as I touch the wave, it's not empty. I hear it's my finger. So it becomes a particle, a zero set. Finish. You are bringing about what you think is happening to you. You are catching your ear and say, oh, somebody's catching my ear. You are the one who's catching his ear. The moment you take measurement, you touch.
You collapse.
You collapse it because it's no more an empty set.
Yeah.
There can be no mass, no more. Simpler. You cannot separate particle from wave.
And both.
Because the wave is the surface. It's called in the mathematics, again, cobordism, the theory of cobordism, which is a very fancy word for the surface.
And they have mathematical values related to the golden mean that we will be talking about ultimately, that you can...
A particle is described according to a fantastic, really fantastic, pure mathematician who is extremely interested in down-to-earth things like physics, theoretical physics. It's Alain. And Alain Connet, and
non-commutative.
Non-commutative. We will talk about that.
Yes, that'll come up. But the values, just for the moment, of these two, based upon the golden mean. One is the wave is...
According to his theory, non-commutative symmetry, and which was an extension of two things. A theory of von Neumann called continuous geometry. But he meant with that, the spectrum is continuous. It means it can be 1, 1.5, 1/3, 1/3. So it is really fractal. But he used a misleading word by saying continuous geometry. You think it's normal geometry. No. Continuous geometry is the spectrum of the dimension is continuous. And if the spectrum of the dimension is continuous, then you don't have 1, 2 dimension, 3 dimension. No. You have 1 dimension, 1.5 dimension, 1 3/4 dimension. Everything is admitted, means it is fractal. It means it is not continuous. You see? So, von Neumann theory of continuous geometry, and he connected and applied to Penrose's universe. Penrose's universe was the golden mean. And he finds that the particle could be described by the golden mean. And the wave described by the golden mean to the power of 2. That is the empty set, and the other one is the zero set. A particle, appropriately, you can imagine it as a zero set. A wave, appropriately, you can imagine it as an empty set. And space-time itself, an emptier set than the empty set. So the wave is really part of space-time itself. So no wonder, whenever it collapses and you leave it, it acquires again a wave around it because it's surrounded with space-time. Space-time is a gigantic, big wave, quantum wave. All this thing comes from pure mathematics, but you can associate with it physical pictures. You just have not to be British to say, I am pure mathematician. I don't think like that. Or I am a physicist. I want a physical the truth of the matter, anything in the long run, we'll have to do this. Anything which is mathematically and logically correct is real, and you will find it in reality.
So the act of measurement, you are literally collapsing one form of the golden mean into another form of the golden mean. The wave is going to the particle.
Yes.
And so the act of measurement, you're going from the golden mean to the golden mean squared. Explain.
Yes. Indirectly.
Indirectly.
And you can see it as in set theory. As an empty set, when you try to touch an empty set, you put your finger in it, you touch it, it becomes non-empty. The nearest thing to an empty set, which is non-empty, is a zero set. You want to jump to something else. You see, there was a question which occupied the mind of Einstein and people inclined like him. Did God have any choice in creating the world as it is? And I thought about that along, and I said, no, God had no choice. Because God invented logic first. Once he had invented logic, he had no choice.
There's no other way.
Everything goes on. And I would define good as something which is logical. And I would define evil as something which is illogical. Everything which makes sense is good. Logic must be our guiding. Everything, we say everything should come from the heart. But this is really a figure of speech, because the heart doesn't think. You just feel your emotion and it excites your nerve system, so you feel it in the heart. But everything really is originating from the brain. And everything which is logically correct will be automatically almost force on you truthfulness and goodness. It's lies and cheat which bring evil. So really, God had no choice in creating anything once he created logic. And he gave us the ability to think logically. And when somebody like Erich Kästner, who was very famous long ago for writing Emil and the Detective, I think it's the most famous.
What is the name again?
Erich Kästner. Erich Kästner. Erich Kästner, he made a small calculation without golden mean, 1, 2, 3. The cost of World War II would have given everybody living on the planet a nice villa to live in. You know? He really published that. You see.